everyone, my name is Dr. Shabin Taj. I am here to present session 2 in the subject data communication or in the subject data communication. Topic will be digital transmission, digital to digital signal conversion and its characteristics. We'll have a quick glance of line encoding which is already discussed, baseline wandering, DC component, why a DC component is required, self-synchronization, error detection, noise and interference complexity. What is line encoding? I've already discussed what is line encoding. Conversion of digital signal to digital data into digital signals is nothing but line encoding. So in this case, what you have to do? You have to choose a good signal element is referred to as a signal encoding. So why you have to choose a very good signal element? Because signal element being the carrier of your data element. So if you choose the wrong signal element, your data you cannot ensure that data will be properly transmitted. Hence, you have to choose a proper signal element. So, for example, I have already given the analogy, signal element being the vehicle which carries the data element, that is person. A person, when you choose a vehicle in order to go from source to destination, obviously you have a good choice rather than bad choice. Good choice in terms of that the vehicle should be in good condition. It should not be compacted, full overloaded, and it should be properly ventilated, and the vehicle should be. These are the choices, the characteristics what prefer data element. A person wants. So again, the vehicle should not be with the problem like it keeps on giving in between. It should not be affected. Okay, so all these things are there. Hence, when you are choosing the good signal element, you have to keep in mind some of the characteristics like baseline wandering, bandwidth, noise interference, all these. We'll see. What is baseline wandering? Here, a receiver will evaluate the average power of the received signal. Average. Your sender is sending, the receiver is receiving. What is the average power? It is consumed, it is received. So this is called as baseline. And this is used to determine the value of the incoming data elements. If the incoming signal does not vary for over a long period of time, that means when you have long ones, when you have long zeros, then there is a baseline drift is there. Thus cause errors in the detection of incoming data elements. That means there are more chances of finding the errors when you have a series of ones and zeros. A good line encoding scheme will prevent long runs of data of fixed amplitude. Okay, so this is what. Next, what is line coding characteristics? Your DC components, that is when the voltage level remains constant. When it remains constant, when you have stream of zeros and ones, it remains constant for long periods of time. That is, for long periods of time, it remains constant. There is an increase in the low frequencies. Low frequencies will be more of the signal. So most channels are band pass. There is two things are there: band pass and low pass. So band pass may not be. Most channels are band pass and low frequencies. That is low pass channels are not at all used. This will ensure. It requires that you need to remove the removal of the DC component of a transmitted signal. Okay. So this characteristic, the DC component should not be there in the signal. What is synchronization? Self-synchronization. Self-synchronization means the clocks of the sender and the receiver should be in the same pace. It should not be the clock is running, the clock is running at 10 a.m. showing and the receiver showing is 10 or 10:05. That means they are not synchronized. They are at the different intervals. So in order to synchronize, in order to receive the same data, it must be synchronized. If the receiver clock is faster or slower, it will misinterpret the incoming bit stream. Yes, whatever data you have sent, it may not be properly decoded in the receiver side. Hence, self-synchronization is required. Now you see the example over here. What is the effects of lack of synchronization? The sender is sending this in which one data element is analogous to one signal element. 0 is this, 1 is this, 1 is this, 0. So it is how many? 3, 6, 7, 8. 8 data elements are sent at the sender in the signal element of that. This is line encoding. Line coding. Now in the receiver side, what it is showing, because lack of synchronization in the one signal element, it is showing 1 and half, approximately 1 3/4 of the data. You can see. And here also say, that means it will misinterpret the data. Absent only 8 bits of data, but it is showing so many bits. So that means it is not properly encoded. It is not synchronized. So you will see a misinterpretation of the data. Let us see one example. In a digital transmission, the receiver clock is 0.1% faster than the sender clock. So that means receiver is running fast, the sender is sending slow. It is at its own speed. So what happens? How many extra bits does the receiver receive? The data rate is 1 kilobits per second. Okay, and how many bits? What is the data rate? What is the extra bits received when the data rate is 1 megabits per second? You can see here. At 1 kbps, the receiver receives 1001 bits per second instead of 1000, because it is 0.1% faster. So if you evaluate 0.1% of the sender thing, you will find it 1 extra is received. Okay. So here again, at 1 megabits per second, the receiver receives this many. That means instead of this, it is showing the extra 1000 bits are received. Hence, it is erroneous. The data is not properly received as per the sender and the receiver. Okay. So hence, synchronization plays a vital role in the transmission. What is encoding characteristics error detection? Yes, errors can be injected during the transit, during the line impairments, or due to lane impairments. Okay, so some codes are constructed such that when error occurs, it can be detected. So some codes can be detected. For example, a particular signal transition is not part of the code. When it occurs, the receiver will know that a signal error has occurred. Okay. Now, next characteristics is what? Noise and interference. So, if a caller calls a callee, whatever he is speaking, if background some noise is coming, that is not desirable, right? So, the signal, your line, your communication line should be immune to the noise and interference. Okay, it should not give chance for that. There are line encoding techniques that make the transmitted signal immune to noise and interference. So, this means what? The signal cannot be corrupted. It is stronger than error detection. So, while transmitting the signal, you should take care that the noise and interference should be, the signal should be immune to the noise and interference. What is complexity? The more robust, the more hard and resilient the code, the more complex it is to implement, and the price is often paid. That means it is like if you want more efficient, more good quality, you're paying the more price. So the complexity is more, the baud, often you are paid in the more baud rate, that means signal rate, or required bandwidth. If the complexity is less, the signal rate is less. These are the references and end of the session 2. Thank you.